Alright, so today guys, I'll be showing you guys how to solve a projectile motion step by step. First, a projectile motion is any launched or thrown object that is being acted on by only the force of gravity. And the key to solving a projectile motion is by separating the x and y parts. The x is the horizontal and the y is the vertical. For example, a cannon shoots a cannonball with a velocity of 60 meters per second at a 20-degree angle off a 20-meter high cliff. How far from the base of the cliff will the cannonball land? So the first thing you do when you're solving these problems is draw the picture. Since the angle it's launched at is 20 degrees, you put the 20 degrees right there, theta equals 20, and the velocity is 60 meters per second. Alright, and step number 2 would be to figure out what you're trying to find. In this case, we're trying to find dx since that's the displacement between where the ball lands and the edge of the cliff. So for step number 3, you identify all the given information. Like I said at the beginning, x and y, you separate those to make it easier for yourself. I circled dx because that's what we're trying to look for. I got dy because negative 20 or 20 is the height of the cliff, and that's the y because it's vertical, and it's negative because the cliff is going down, or the cannonball is going down at that height. And you're probably wondering how I got VIX and VIY, and it's pretty simple. So the given information, 60 meters in the 20 degrees, you set those up as a right triangle. So the 60 meters is the hypotenuse, and the 20 degrees is one of the angles. And to find VIY, you use sine because that's opposite over a hypotenuse. And to find VIX, you use cosine, which is adjacent over a hypotenuse. And the value of VIY is 20.52, and the value of VIX is 56.38. And AX is always given to you, it's always 0. And AY is negative 9.8 because that's the force of gravity that's pushing onto the cannonball. So for step number 4, you choose one of these 4 equations. But in order to use one of these equations, either for the x or y values, you need 3 given information. And for x, you only have 2, but for y, you have 3, so you could use either one of these equations to solve for t. We're solving for t because for both of these values, t is the same. So if you get t on the y side, you also get t on the x side, and since once you have the t, you have 3 given information, and you could solve for dx. So what I did in step number 5 was use the 4th equation to solve for vfy squared. And the first thing I did was square root vfy squared to get rid of the squared, and I had to do it to the right side because whatever I do to the left side, I have to do it to the right side. And once that, I just plugged in all the values. So for example, VIY squared was 20.52, and AY is negative 9.8, and DY is negative 20. And I plugged all that into the calculator, and I got 28.51 meters per second. But it's negative because VFY is the vertical, and since it's going down, it has to be negative. That was one mistake I made right there. So its VFY is negative 28.51 meters per second. And now, once I have gotten negative 28.51 meters per second, I could use the first equation to solve for t. So now that we found the value of what VFY equals, we could use the first equation, as you can see at the top right corner, the first equation to solve for t. But first, in order to solve for t, you have to get the variable t by itself, and to do that you use basic math. You subtract VIY from both sides, and that gives you VFY minus VIY equals AYT, and you divide AY to both sides to get t by itself, and the equation I squared there is the equation we use to solve for t. So now that we know the equation, you just plug in numbers, and since there it's negative 28.5 minus 20.52, since they're both negative, negative plus a negative, you just add them up. So yeah, so negative plus a negative, you just add them up, so it's 28.5 plus 20.52 over negative 9.8, and that gives you t equals 5.002 seconds, or you could just leave it at 5 if you want. So now that you know that t equals 5.002 for the y section, you also know it for the x section, since their times are both the same. As you can see, the little arrow I drew. And now that you have 3 pieces of information for the x side, you could solve for dx, and the equation you use to solve for dx is dx equals vix times t plus 1/2 ayt squared, and you just plug in your values. So for vix it's 56.38, and for the time, which is t, is 5.002, and ay, since it's 0, whatever you multiply to 0, it's gonna equal 0, so I just crossed it out. So the answer is dx equals 282.01 meters, and that's how you solve projectile motion. Thanks for watching, guys.